All right, our last video, this last example, we are going to work on solving a system of equations in 3 variables. You guys have not seen this before. Did you know that you can have an equation that has an x, a y, and a z in it? And that's actually something that you could plot. There are 3-dimensional coordinate planes that have a z-axis. We'll see if we get to some of that in this new Algebra 2 curriculum. But we're going to start by solving a system in 3 variables. Our goal is to whittle this down to 2 variables. You can only work with 2 equations at a time. So I'm just going to go ahead and pick the first 2 equations. And I'm actually going to write a little closer because this might take up some space. So 2x plus y minus z equals negative 10. And then I think the one below it looks good. We have a negative x plus 2y plus z equals 3. I want to eliminate either the x's, the y's, or the z's. Right now, the z's will eliminate quite nicely. A negative z plus z is 0. They cancel away. So I'm just going to go ahead and add these 2 equations. 2x plus negative x is x. Y plus 2y is 3y. Your z's cancel. Negative 10 plus 3 is negative 7. All right. I'm going to need that in a minute, so I want to hang on to that, put a box around it. We need another equation with just an x and a y. So I might just grab the second 2 equations. This negative x plus 2y plus z equals 3, and x plus 2y plus 3z equals 13. Okay, so because I chose to eliminate z's originally, and I have an equation with just an x and y, I have to do that same thing over here. I want an equation with just an x and a y. Right now, the z's do not eliminate. Z plus 3z is 4z. But we can make that elimination happen if we multiply this top equation by a negative 3, and we're allowed to do that as long as we multiply every single term by a negative 3. That's going to get us a negative 3z, which will cancel with that 3z. So I am just going to say, okay, we got to do this work over here. Multiply the top equation by negative 3 will give us negative 3 times negative x is positive 3x. Oops. Negative 3 times 2y is a negative 6y. Negative 3 times z is negative 3z. That's what we wanted. And negative 3 times 3 is negative 9. The second equation didn't change. I'm just going to carry that over. X plus 3z. Nope. X plus 2y. Need to make sure we're looking very carefully. Plus 3z equals 13. All right, so now we can add these equations together. 3x plus x is 4x. Negative 6y plus 2y is negative 4y. Your z's cancel. And negative 9 plus 13 is a positive 4. So here's my second equation we have with just an x and a y. So what we're going to do now is we're going to take these 2 equations and put them together as a new system. X plus 3y equals negative 7. 4x minus 4y equals 4. And we're going to solve a system of equations. Elimination probably is the easiest for this whole process. We can eliminate the x's if this top one was a negative 4x. So why don't we go ahead and multiply the top equation by negative 4. I'm going to rewrite that over here. So negative 4 times x is negative 4x. Negative 4 times 3y is negative 12y. And negative 4 times negative 7 is a positive 28. All right, the bottom equation did not need to change, so I'm just going to copy that over. 4x minus 4y equals 4. And then we're going to add these 2 equations together. When we add those together, our x's will cancel. Negative 12y plus a negative 4y is negative 16y. 28 plus 4 is 32. And now we can find the value of y. We got it down to one variable. Let's divide both sides by negative 16, and we get y equals negative 2. All right, so y equals negative 2. Our answer, we can write it two ways. We can say x equals, y equals, we know that's a negative 2, z equals, we don't know yet. You also can write it as an ordered triple, I guess you would call it. You'd have your x, then you have your y, then you have your z. So as we find the other two, we can fill them in. Now that we have y equals negative 2, we are just going to backtrack and start plugging things in. So I can go back to either this equation right here or this equation right here. Because I'm looking for an x next, I'm going to plug into this one. I think that one looks easier. So if I plug into that equation, x plus 3 times, now that we know what y is, we're just going to plug in a negative 2 for the y, equals negative 7. 3 times negative 2 is negative 6. Then we're going to add 6 to both sides, and we get x equals a negative 1. So I'm going to fill in x equals negative 1 up top, negative 1 into our ordered triple, and now we go back to one of the three original equations to find the z. I know what x I can plug in, I know what y I can plug in, and so we just pick whichever one looks easier. We are solving for z. This positive z right here looks easiest to me, so I'm going to plug into the second equation. I'm going to do that work up here. So plugging into that second equation, we have a negative x. So negative, our x is a negative 1, plus 2 times a negative 2. Again, I'm plugging into the second equation right there. Plus z equals 3. All right, a negative negative 1 is 1. 2 times negative 2 is a negative 4. Plus z equals 3. 1 minus 4 is negative 3. Plus z equals 3. And then we just add 3 to both sides, and we get z equals 6. So I'm going to go ahead and fill in. We know that z is a 6, and we can write it in our ordered triple in the z spot. And here we have our solution. One down. So clearly these are long examples. We have one more example to go through. I'm going to start a new video for that one. So this will be part 1, that'll be part 2.